Welcome to our module on testing and debugging, crucial skills for developing reliable software applications. These are truly essential skills that ensure you build robust and high-quality software from the start. Let us begin by exploring the core benefits that unit testing brings to your development process. It is a fundamental approach for ensuring excellent code quality right from the initial stages of development. First, unit testing excels at error detection, helping you find and fix problems quickly. This proactive approach identifies bugs very early in the development cycle, saving significant time later on. Next, unit testing significantly improves code quality by encouraging better practices and modular design. It promotes writing cleaner, more organized code, which is easier to maintain and understand over time. Unit tests also provide excellent refactoring support, giving you confidence when making changes to your code. This guarantees that any modifications you make will not inadvertently break existing working functionality. Finally, unit tests serve as living documentation, clearly outlining the expected behavior of your code units. They show how individual components should function, which is invaluable for new developers joining a project. Now, let us walk through the process of installing the PHP unit framework for your projects. We will cover the step-by-step setup using Composer. The PHP Dependency Manager. To install PHP unit as a development dependency, you will use the Composer require command as shown here. This command installs PHP unit into your project's vendor directory, marked specifically for development use. After installation, verify the PHP unit version by running this command in your project's vendor bin directory. This step confirms that PHP unit is correctly installed and ready for you to start writing tests. Let us explore the fundamental structure and components that make up a typical PHP unit test file. Understanding these building blocks is crucial for writing effective and maintainable unit tests in PHP. The first key component is the test class, which serves as the container for all your individual test methods. This test class must extend the PHP unit framework test case class, inheriting essential testing functionalities. It also provides convenient setup and tear-down methods, allowing you to prepare and clean up test environments. Next, we have the test methods, which are the actual functions containing the specific logic for each test case. These methods encapsulate the precise steps needed to verify a particular unit of code's behavior. Each test method must either be prefixed with the word test or be annotated with @test for PHP unit to recognize it. Finally, assertions are critical statements within your test methods that verify if the expected outcomes are met. These statements allow you to programmatically confirm whether your code behaves precisely as you intend. Assertions essentially check if the actual output of your code matches the predefined expectations for a successful test. Let us now look at common PHP unit assertions in action, demonstrating how to verify expected outcomes. These assertions are vital for confirming that your code behaves as intended during various test scenarios. We will start with the assert equals method, a fundamental assertion for comparing values. The assert equals method checks if two values are equal, commonly used to verify function return values. This assertion checks if the result variable equals 5, providing a helpful message if the addition fails. Next, we have the assert true method, which is useful for validating Boolean conditions. The assert true method verifies if a given condition or value evaluates to true, essential for Boolean checks. Here, assert true verifies if the isValid variable evaluates to true, indicating a successful condition. Now, let us examine the assert null method, used to confirm the absence of a value. The assert null method checks if a variable or expression evaluates to null, ensuring the absence of a value. The assert null method confirms that the value variable is indeed null, ensuring its absence. Finally, we will explore the assert count method, which is perfect for validating collection sizes. The assert count method verifies the number of elements in an array or any countable object efficiently. Finally, assert count checks if the array contains exactly 3 elements, reporting any count mismatches. Now, let us explore the key features of Postman, a powerful tool for API testing. Postman truly powers API testing and development workflows, making interaction with APIs much simpler. Postman provides robust request building capabilities, allowing you to craft detailed API requests. Send requests with various HTTP methods, including GET, POST, PUT, and DELETE, effortlessly. You can easily configure headers and various authentication methods for your API calls. Set custom headers and authentication types like bearer tokens or OAuth to secure your requests. Postman supports multiple body formats for sending data, accommodating different API requirements. Send data in JSON, XML, or form-encoded formats, ensuring compatibility with diverse APIs. After sending a request, Postman offers comprehensive response inspection features, status codes, headers, and the raw data returned, helping you understand the API's behavior. Moreover, Postman provides powerful automation capabilities, allowing you to script your tests. Write JavaScript tests to validate responses, ensuring your APIs always behave as expected. Let us move on to testing APIs with Postman. Executing common HTTP methods for interaction. We will see how Postman helps you interact with APIs by demonstrating the main HTTP methods. First, we have the GET request, a fundamental method for retrieving information from a server. A GET request is used to fetch data from a specified API endpoint without modifying resources. Next, consider the POST request, which is used for submitting data to create new resources. A POST request allows you to create new resources on the server by sending data in the request body. Then, there is the PUT request, designed for updating existing resources on the server. A PUT request is used to update existing resources on the server, typically replacing the entire resource. Finally, the delete request is used for removing resources from the server. A delete request is specifically designed to remove resources from the server, indicating their deletion. We will now explore front-end debugging techniques, focusing on browser developer tools for UI inspection. These techniques are essential for leveraging browser developer tools to effectively inspect and debug your UI. One key technique is inspecting elements, allowing you to examine and modify your web page's structure. You can modify DOM and CSS in real time, seeing immediate visual changes on your web page. This helps identify layout issues, styling problems, or elements that might be unexpectedly hidden. Another crucial technique is console logging, which provides insights into your application's runtime. You can log variables, errors, and application state directly to the console for easy inspection. You can use console.log, console.error, and console.warn for different logging purposes. Network tab debugging is also invaluable for understanding how your front-end interacts with servers. This tab lets you inspect API requests and responses, showing data flow between client and server. You can check HTTP status codes and payloads, quickly identifying issues with data exchange. For in-depth code analysis, the source tab for JavaScript debugging is extremely powerful. Here, you can set breakpoints to pause execution at specific lines, allowing detailed inspection. Step through code line by line to inspect variables and understand the program's flow at any point. Let us now shift our focus to back-end debugging with logs and exceptions for server-side issues. We will explore how to track server-side issues by gaining valuable insights from your code through these methods. One effective approach is log-based debugging, which involves writing messages to server logs. The error log function writes messages to the server's error log, helping trace execution flow and variable values. This code demonstrates using error log to track database connection status and the value of a variable. Another critical technique for back-end debugging involves robustly handling exceptions. Using try-catch blocks allows graceful error handling and logging detailed messages when unexpected issues occur. A try-catch block handles errors gracefully, logging detailed messages when unexpected database issues occur during queries. Let us compare Selenium versus Cypress for end-to-end testing. Two popular tools in web application automation. We will highlight their key differences, helping you understand which tool might be better for your automation needs. First, let us look at the various features we will use to compare these two powerful testing frameworks. Considering programming languages, we note how each framework handles different coding environments for test development. Next, We will examine the complexity involved in setting up each testing framework before you can begin writing tests. We will also compare their capabilities for real-time reload, which can significantly speed up your development cycle. Moving on, we will assess the overall debugging experience offered by each tool, a crucial aspect for test maintenance. Finally, we will consider their performance and speed specifically when testing modern, single-page web applications. Now, let us examine the characteristics and capabilities of Selenium based on the features we just outlined. Selenium is quite versatile, supporting multiple programming languages like Python, Java, JavaScript, and PHP for test scripting. However, Selenium often requires separate browser drivers, which adds a layer of complexity to its initial setup. A significant point to note is that Selenium does not inherently offer real-time reload during test execution. The debugging process in Selenium can sometimes be more complex, often requiring external tools for effective troubleshooting. For modern single-page applications, Selenium can sometimes be slower due to its architecture and interaction model. Let us now turn our attention to Cypress and see how it compares to Selenium in these key feature areas. Cypress is primarily focused on the JavaScript ecosystem, meaning tests are written exclusively using JavaScript. Installation of Cypress is straightforward, typically involving a simple npm command, making setup quick and easy. A major advantage of Cypress is its built-in live reload feature, which enhances the developer experience during testing. Cypress offers an integrated and detailed debugging experience, complete with clear logs and snapshots directly in the browser. For modern web applications, Cypress generally provides faster test execution due to its architecture and direct browser interaction. To conclude, let us summarize the key takeaways from our discussion on testing and debugging. These are the essential points you should remember to apply robust testing practices in your development. Unit testing isolates components to ensure correctness and significantly improves overall code quality. PHP Unit is the widely recognized standard framework for effectively unit testing PHP applications. Postman is a highly versatile tool for efficiently testing, automating, and documenting. APIs. Browser dev tools are indispensable for front-end debugging, inspecting elements, and monitoring network activity. Back-end debugging relies heavily on server logs, IDE, breakpoints, and thorough database query analysis. End-to-end testing, using tools like Selenium or Cypress, verifies full application workflows from start to finish.